We'll now look at one additional example from section 7.2, where we are discussing the sum and difference identities. Our example reads, assume cosine u is equal to negative 24 over 25, and sine v is equal to 5 over 13. Angle u is in quadrant 3, and angle v is in quadrant 1. Find cosine of u plus v. So in order to work this problem, we're going to draw two triangles. We're going to draw an angle for u and an angle for v and make each of these a triangle. So the problem tells us that angle u is in quadrant 3. Remember, your quadrants go counterclockwise. So this is 1, 2, and 3. So I'll put my angle in quadrant 3. And so this is angle u, although we're going to use the reference angle between the terminal side of the angle and the positive and the x-axis. So I'm going to label this angle u, and I'm going to extend a line making a right triangle. Now, what do we know about that triangle? We know from our SOHCAHTOA definition that cosine is the adjacent over the hypotenuse. So we know that the adjacent side is negative 24, and we are going to go ahead and put the negative on it to indicate that we're moving towards the left as we move across that side. And the hypotenuse is 25. Then we can use Pythagorean theorem to find our missing side. So we'll have negative 24 squared plus the missing leg, which we'll call b, is equal to 25 squared. Negative 24 squared is 576. (25 squared is 625. Subtracting 576 from both sides gives me b squared is equal to 49, which implies that b is going to equal 7. Again, this 7 is going to be negative because we're going to move down on that side. Okay, so let's construct a second triangle for v. So the problem tells us that v is in quadrant 1. So we'll draw our angle in quadrant 1. We'll drop a line down to make a right triangle. And let's fill in what we know. By SOHCAHTOA, we know that sine is the opposite over the hypotenuse. So the opposite side will be 5. The hypotenuse will be 13. And again, we can use Pythagorean theorem to find the missing side. So we can say a squared for our missing side plus 5 squared for the other leg is equal to the hypotenuse squared. So we'll have a squared plus 25 is equal to 169. Subtracting 25 from both sides gives us 144 for a squared, which implies that a is positive 12. And both of these values are positive because as we move from the origin across the sides of the triangle, we're moving in a positive direction on the 12, and then we're moving up, also in a positive direction. So once we have both of our triangles drawn, we're ready to look at what we're being asked to find. The problem asks us to find cosine of u plus v. And we have our formula listed here. So we know that that's equal to cosine u times cosine v minus sine u times sine v. So what we need to do is we need to use our pictures to identify each of these four values. So cosine u, I'll look at my u triangle. I'll remember that cosine is adjacent over hypotenuse. So adjacent is negative 24, and the hypotenuse is 25. Cosine v, so we'll move to the other triangle. Cosine is adjacent, so we'll have 12 over the hypotenuse of 13. Sine u, so going back to the u triangle and doing the sine, sine is the opposite over the hypotenuse. So negative 7 over 25. And sine v, opposite over hypotenuse, we'll have 5 over 13. So as we simplify, we're going to multiply on the top of the first two fractions, 24 times 12, which gives me negative 288. And 25 times 13, which gives me 325. On my second set of fractions, negative 7 times 35, or negative 7 times 5 is going to give me negative 35. 25 times 13, again, is 325. So we know that this minus and a negative becomes plus a positive. And adding our two fractions together, negative 288 plus 35 gives me negative 253 over 325. And this will be our final answer.